So welcome. Now we continue in Julia, looking at interactive work on the compute nodes. And I can make this a bit bigger. This. Yeah, so after today, we hope that you can start an interactive session using the compute nodes in an interactive manner, and also using the Julia REPL in the interactive session. And also be able to run Julia in Jupyter Notebook or Pluto. And you can choose which one of these are interesting for you. Yes. So you can run Julia directly on the login node, including ThinLink login nodes. So this is where you come when you log in. But as mentioned before, only done for shorter jobs. And when you are not using too much resources like memory or cores. But sometimes you want to work interactively with your code or data. So testing scripts, looking at figures and such. So more interactive development or basically looking at data. So then you should start a kind of interactive session, because otherwise you would like to run a batch job. But what you cannot do then is to interact with the program. Yes. So you need to have compute nodes allocated and at the same time work interactively. And this is done through the Slurm system. And this can be done in several ways. We have a parallel session about on demand. This will work on, we can scroll down a bit. We have, for instance, open on demand on HPC2N, Kebnekaise that is, or using GFX launcher at LUNARC, and the same at PDC. Otherwise, one can use these commands, interactive, which is what we recommend. As alloc is also something built in Slurm, that interactive is a so-called wrapper, and it also includes things that are good on the cluster, like X forwarding as well. And so this makes it easy to use graphical interfaces. Yes. One can, we have some differences. Yeah, I just mentioned HPC2N and UPPMAX, but we actually list several clusters here or centers. At all the places, when you allocate compute nodes and get the resources, you are actually on a compute node. So whatever command is done here, it is run on the compute node. And you see the details here for LUNARC and NSC and PDC. HPC2N Kebnekaise, you actually remain on the login node. But if you use this key command, srun, that tells Slurm that you are running on not the login node, but on the compute node. So when you have allocated resources and use this keyword srun, you actually start to do something on the compute node. Yes. So we have, for instance, how it looks like. In most centers, we come to the login node, and you can send a job with the S batch. Then you get a job done on compute node, which you predefine in this batch script. So you define what to do, and then you send it, and then you cannot change anything. But with interactive, you use this interactive command, and you come to the user or compute node. Yeah, you are on the compute node, and you can run some either scripts, or you can start the REPL or a graphical interface like Jupyter or Pluto, which we will mention in a couple of minutes. When you are done, you can exit back to the login node like this. Yeah. So this is how to do. At NSC, this is what I will show you, but there are similarities at the other clusters. You see that at PDC, you have this salloc key command instead. But otherwise, it looks like this. And HPC2N is also salloc. So as with the batch job, you can define also on the command line the number of tasks or cores, the time, and your project. And when you get your allocation, you can run the program or start the REPL with this command. Yes, and the extra things about HPC2N, I will not cover it. You can read this yourself. So when you're finished, you use this exit command or log out to be able to actually kill the session, because otherwise it will tick. Your core hours will be used and you do nothing. So an a batch job is very efficient, because then the batch session is over when your workflow is done, when your S batch script or when the job has done what is in your batch script. So that is rather efficient way to use the resources. On the interactive session, as long as you are logged in, and if you have several cores, you will be billed like, yeah, for instance, if you book 3 cores and you have a session up for 12 hours, you have 12 times 3, that's 36 core hours. So this will be wasted if you're not using if you're not working with your development or your data in an effective manner. So unless the queues are very long, you can, when you have a lunch break, for instance, you can log out and then log in again. But of course, if there is long queues, then you may find out that it's better to actually book the whole day and run 8 hours and then work as much as you can. Yeah, we have local documentation here. So the exercise here is to try to do these things. I suggest you to use ThinLink so that you are able to start also later Pluto or Jupyter, which are graphical, and then ThinLink is much better compared to if you were using SSH. Yes, but we can start a terminal shell from ThinLink. So I can just show you the steps for NSE. So here I have a ThinLink client like that. And let's start a terminal, and you see now that this keyword thetalit2, this is login node 2 for thetalit. I will now try this interactive and starting how many cores? Well, 4. -n equals 4. And I only book 30 minutes. So I think, yes, I copy this. And at least for me, in ThinLink, well, you can either right click and do paste, or I can use Shift Insert. Shift Insert will, I thought, no. Okay, let's do this again. Copy. And then I shouldn't touch anything here because then it will be copied automatically. Here it is, yes. Oh, granted. Waiting for resource configuration, and it's already up. No queue. It was very nice today. So now see that N135 4. This is on a compute node, number 134 actually. So we can see the difference here from this and the login node, which is the whole name thetalit2. So this is node 134. We can start this program, or load the module for it. Insert, shift insert, like that. We can check with ML module list, and we see that this is here. Let us now check that we actually run on a compute node. First, we can try to just type host name, and it will give us this N134. We can also do srun host name. Then it's run 4 times. And this is because we actually allocated 4 cores. So this hostname command is run once on each core. So in an so-called embarrassingly parallel way. So you run the same command on the 4 nodes at the same time. Yeah. 1, 3, 4. Okay, so we are here. Great. Now let's add 2 numbers. I will start nano, and well, it might be in the exercise folder that you have worked with before. Or I think I will not show this, but instead just, yeah, precisely. Let's see, maybe I have it here. Maybe documents. No, okay. Courses. Okay, sorry. It is not in Julia. I'm quite sure about that. Yes, okay. Here we have the Pluto environment on the other hand. Okay. But I can just mention, so if we run srun and then Julia and then the serial sum file, we have the input arguments x and y. So we are parsing 3 and 4, and then we calculate the sum, which is in this case is 7. And this is run 4 times. So this serial program using this srun, this will be run 4 times embarrassingly parallel. Yes. So if we don't use the srun, it will only run once. But if you are having, like we will see in the advanced session, where we use distributed or threading or MPI, Then by this, we can actually run real parallel. We can also start the REPL. So using this -p, you can try this. So Julia -p, and we can first try allocate 5, see what happens. Remember that we only booked 4 cores. We can try n workers. It is 5. Interesting. Yeah. You may learn on the advanced day that you can distribute more workers than are available as cores. But usually you will put this to the number of cores you have. Adding 5 will not make it, well, it will run four processes first, and then Julia will wait for the 5th. So when one process is ready, it can start the 5th. In some cases. Okay, let's go out from here. I use the Ctrl-D command, and we are back. Now we could exit, but I won't do that because I will just say some words about notebooks. So Jupyter was written for serving notebooks for Julia, Python, and R. And you may see here, this is Julia, this is Python, and here we have R. So all these can be available. And here we see Python, and we have also Julia kernel, different versions. And it can look like this. So notebooks and it can look like this, yes. If you are interested, there are many courses about Jupyter online. So if you are interested, you can dig deeper. Then we have something called Pluto, which is like Jupyter, a programming notebook, but it is native, so to speak, to Julia. And that looks like this, quite similar. I didn't show this, but you can have graphs also in Jupyter. What is a bit different, or I guess Jupyter has some of these things, that it is reproducible, gettable, extraordinary, interactive programming. What is different from Jupyter is it understands so-called global references between cells and reactively re-evaluates cells affected by a code change. So it's a smart way. Yeah, so yeah, it works better, so to speak, and you can read more about Pluto. So the exercise now is to start either Jupyter or Pluto, and you should use ThinLink and also from the terminal having started an interactive session like I did here, or see the last exercise. After you're done, it can look like this. So you do exit, and then you have the output telling you that you will come back. You see also in the end that now you are back on login node Tetralit. And we also have some exercises for if you are interested. So you can try to run some scripts from the batch Julia session and such. And I can just show Jupyter. I hope that you in an earlier session install iJulia. Otherwise, you can do this again. And usually it works like this. So you in Julia's session starts in notebook, and then depending on where you are, well, you should start web browser. In most cases, it's Firefox, I think, on the different clusters. And if you are on a compute node, you can run it like this, IP hostname. At PDC, yes. So see here also that you have to load both Julia and Python. And for Pluto, you activate your Pluto environment, then using Pluto. And yeah, the same would be also for your Jupyter session, yes. In some clusters in Julia, just Pluto run could work. Otherwise, do this. So launch browser false, then note the URL given, paste it into a browser open from the menu in ThinLink. Otherwise, do, especially if you are running on an interactive session, then you run this command instead and call host 0000. And it will give you some output, and copy and paste this URL and put it into the browser. But also note the node you got when you created this interactive session. So in this case, it was N134. But if it's N701, you interchange this 000 to this one, and otherwise keeping what you got from the output when you started Pluto run. Yeah. So when you have this in the URL, you can you will come to something looking like this. You can start a new notebook or open an old. You can also go to different getting started sessions where you can follow and learn the basics. And here, yeah, this is what I showed you before. So good luck with these exercises. And I will end this session. See you.